Hey, in this video I want to talk about the final keyword, which was also introduced in C++11 just like the override keyword. The final keyword can be applied to classes or to member functions, so virtual member functions. And we'll start off with the final keyword as applied to classes. Just like the override keyword, the final keyword is also a contextual keyword, and the final keyword can be used to designate classes that cannot be derived from. If you try and derive from a class that is specified as final, then you'll get an error. The final keyword follows the class name in the class definition. As you can see in this example, we have class, some class name, and then final. Now this class can inherit from some other class, some base class name. You can specify that to the right. Here's a quick example. I have the class base. I specify that as final, and I try and publicly derive from the base class. That is going to give me an error. Derived cannot inherit from base, because base is specified as final. You can also specify some derived class as final. So here we have class derived, which publicly derives from the base class. And you can see we also specify this as final, so we cannot derive from the derived class. Here's a quick example for you. I have class parent, class child, which publicly derives from class parent, and grandchild, which publicly derives from child. If I go and specify the parent right here as final, you can see I get a squiggly right here. A final class type cannot be used as a base class. If I Ctrl B to build, we get child cannot inherit from parent as it is declared as final. Now you can do a similar thing with child, so here we can do class child final, and that is going to publicly derive from parent. Then we'll get an error right here. A final class cannot be used as a base class. Alright, go and build around that again, and you will get that error again. Grandchild cannot inherit from child. Of course, if you comment that out, build a run, and this will work fine now. So it specifies the child class as the final class in the inheritance hierarchy, so you cannot go and derive from child. We can also use the final keyword with virtual member functions. The final contextual keyword can be used to designate virtual member functions that cannot be overridden in derived classes. The final keyword is going to follow the signature of the virtual member function declaration. Similar to the override keyword, it's going to come last, or in other words after the parentheses or after the const, if the function is const qualified. Similar to the override keyword, a virtual member function is specified as final only in the class definition. So in other words, where the function is declared, and you're not going to repeat the final keyword in the definition of the member function. That is in the case when you separate out the declaration and the definition of that member function. You can see a quick example at the bottom of the slide. We have virtual void toString, const, and then final, followed by the body if it is defined in the class definition, or we'll end that off with a semicolon if it is defined separately. In this quick example, I have the base class again. I have virtual void toString, which is going to print out base toString, and then I have the derived class, which publicly derives from base, and we also have this virtual void toString, and this is specified to override the base class version. Then in main, I do base pointer, which is pointer to base again, and I allocate derived on the heap. So I do base pointer toString, build run, and we get derived toString. Okay, we've seen this example before, but what if I want to make sure that this function does not get overridden in derived classes? Well, I go and specify that as final. Now you'll see we get a red squiggly in the derived class, where I try and override that function. Cannot override final function base toString. Ctrl B to build that. Base toString function declared as final cannot be overridden by derived toString. Okay, so that allows us to enforce that we do not want this function to be overridden in derived classes. And of course I can go and comment that out and build a run, and now my program will work again, but in this case we'll now get the base toString version of that function. Okay, here's a quick bonus example for you. In the base class, I go and declare the toString function. So I don't have it defined in here, I just have it declared. So I do virtual void toString const. Then in derived I have something similar. I have virtual void toString const and the override keyword or specifier, and I end that off with a semicolon. This is what the declaration is going to look like. Quite a few keywords in there. We have virtual, void, and then we also have const and override. Then I have the main function, and then following main, I have the actual definitions. You can see with the derived, as I mentioned, you are not going to specify this as overridden. That is, we actually define the function. You are simply going to qualify the name to the class type, provide the return type, and then maybe const as well. So you provide the signature and the return type, and then you qualify it. And of course, this is going to be similar in a .cpp file. That is if you separate things out in header and source files. Okay, I'll scroll up and now I'll do final, and of course, with that final keyword, we cannot go and override right here. So I'll comment this out. But before I do, I want to comment out the definition. So I can right click on that and I can go to definition, and that will jump down to that definition. These files can be huge. You can have like 5,000 lines of code. So you want to get to the definitions quickly. So always remember the right click context menu. Okay, I'll go and comment that version out. Comment that out in the derived class definition as well. And that works fine, but now of course we'll get page to string, even though we have a derived object on the heap. Okay, so just a quick bonus demonstration for you. In the case where we have a separate definition, right, where we separate out the declaration and definition of your member function. So we have the override and the final keywords as covered in this and in the previous video. Alright, I hope this video was interesting. I'll see you next time.